This conference will now be recorded.
Right, let's start today's session. So in the last session of Python, we were discuss about operators concept in Python. No? So we have seen some basic operators and we'll continue from there where we stop. So actually Python supports these operators like arithmetic operators, next relational operators, and next assignment operators, assignment operators, and next what we can say logical operators, logical operators, and then membership operators, membership operators, and next identity operators, identity, and then finally bitwise operators, bitwise operators. As I mentioned in my previous lecture, so we will use all the operators like arithmetic, relational, assignment, logical, membership, identity. Every operator is important for us, but except bitwise operator. Bitwise operators I am not at all going to use in our upcoming programming. It's not required for us, but even though it is not required, I will explain you bitwise operators, why and how to use it also. But no need to focus on bitwise operators. Focus on remaining operators. How much focus you want, you can do it on it, but bitwise operators are not required. Generally, bitwise operators can be used in uh, what we can say embedded programming, VLSI, MATLAB, digital circuits, scientific computing. In that context, we can use, but in the normal software programming, we use these operators clearly. We have seen in the last session arithmetic operators, relational operators, assignment operators. Now today we'll start with logical, membership, identity, bitwise. So logical operators are simple and straightforward. And now you can see logical operators are this one only. And will return true if both the conditions are true. It's very simple and straightforward. And will return true if both the conditions are true. Else, it's simply written what's are false. So and operator, logical operator return true if both the conditions are true. Otherwise, it returns simply false. Let's look the example here. So I'm trying to say this print directly. I'm using the values. If you want, you can take the variables also. 3 less than 4, correct. And 2 less than 5, correct. Look at this. Both are correct. 3 less than 4, correct. And 2 less than 5, correct. So both are correct. Both conditions are correct. And will return what? True only. So that's what here you can see and is returning true in my output window. It's written true. So if any one of the condition is false, for example, like 13 less than 4, is this right? 13 less than 4? No, it's not right. So 13 less than 4 is not a correct, but 2 less than 5 is a correct. Only one of the condition is correct. So in that context, obviously result is what's a false. It's a false only. So both condition must be true in the AND operator. AND means both condition must be true only. If any one of the condition is false, then result is false. If both conditions are false, result is false. In this case, look at this, both conditions are false. 13 less than 4 is false, 12 less than 5 is false. Both are false. That's what false. Any one of the condition is false. 3 less than 4 correct. 12 less than 5 false. Any one of the condition false. When it will be true means both conditions are true, then it will be true only. And means. This also can be used in our logical programming. AND operator return true if both the conditions are true, otherwise it return false. Next we have one more logical operator OR. OR will return true. When it will return true? If both the conditions are true, both the conditions are true, or any one of the condition is true, any one of the condition is true. any one of the condition is true, else it return what simply false. Look at this. Or will return true if both the conditions are true or any one of the condition is true. Otherwise, it return false means both the condition false means false only. Okay. So return true if both conditions are true, and return true if any one of the condition is true. If both conditions are false, obviously false only. Or will return to that. Suppose here I'm trying to say or. 3 less than 4, correct. 2 less than 5, correct. R will return correct, that is true. Suppose here you can see 13 less than 4, false. 2 less than 5, true. That means any one of the condition is true, no? That's what, because of this condition is true, even though first condition is false, the result will return what's a true only. Any one of the condition true, result is true. When it will become false, if both the condition is false, 13 less than 4 is false, 12 less than 5 is false, both false, then return is result is false only. So 13 less than 4 or 12 less than 5, both are false only. So that's what it return false. So this is our condition. And there is one more logical is there, that is return not. So it is opposite, sir. It return true if the condition is false. Return true if the condition is false, and it return false if the condition is true, sir. If the condition is true, so opposite you can say this. Not means not true means what? False. Not false means what? True only. So it return true if the condition is false. It return false if the condition is true, sir. Here, let's see this how it will be. So the originally 12 less than 5 is not correct. Look at this, 12 less than 5 is correct? Not correct. False, sir, it is. So if I'm asking you, if I say not of 12 less than 5, what is this? Not of 12 less than 5, result is false, but you are applying not false means true only. Simple. But original result 2 less than 5 is what actually true. But you are saying not true. Not true means what actually it's a false only. So similarly like this, if you can try like this also is possible. True means true only, but you are saying not true means what? It's a false only. Look this, not true I'm taking, it's a false condition, sir. Not true you're saying. False. Obviously false it is. So this is not operator. So logical AND means it return true if both the conditions are true. Otherwise it return false. Logical OR means it return true if the both conditions are true or any one of the condition is true, otherwise it return false. Logical NOT means return true if the condition is false or it return false if the condition is true, sir. This is logical operators in Python. We will use these operators rapidly in our upcoming sessions in the logical programming like if condition, else condition, for loop, while loop, anywhere we can use that things clearly. Okay. Now coming to this membership operators. These are very simple operators, but it's looking new for you. Mostly in all languages like arithmetic, relational, assignment, logical, bitwise. It's a common operators which will be available in C, C++, C Sharp, Java, anywhere. But membership operators are what actually here? Okay, what is membership operator? Why do we use this membership operators? We'll discuss in detail now. See, simple. We were discussing previous example. Okay. So list data structure, string, basics, all these things. For example, I'm taking list only, sir. List. In this list, okay. So I'm taking list of values. You know how to create list in Python. Python list can be created by using square bracket. So we use this bracket and enclosed within the bracket. So all the elements are included here. So these are all members of this list or not? Yes. 1, 2, 3, like 10, 20, 30, 40, 50. These are all members of this list. Do you want to check one of the member is available in the list or not? Yes, we can go for membership operators. So what is the membership operators means? Membership operators are used to check Membership operators are used to check whether whether the value whether the value or element element is present in given sequence or not, is present in given sequence or not, given sequence or not, we can able to find. Okay, membership operators are used to check whether the value or element is present in given sequence or not. It will check. So, what are the membership operators in Python, sir? These are the membership operators in Python. Let's see this. These are the membership operators. And in, not in. In is one of the operator. Not in also one of the operator. And moreover, you can observe here, in is a keyword, not is a keyword. You can go and check out in keyword list. There are some keywords are associated in and not in like that only. Okay. So in, not in. Okay, in, not in. Now coming to this in, it returned true, sir. It returned true when if the value or element present in present in the sequence present in the sequence can be of any sequence like list or tuple or set or anything. In operator will return true if the value really present in the sequence, else it return false. Simply it return false. Not in will do like this. It will return true. It return true. Not in return true if the value is not present in sequence. Is not present in given sequence. Else it return false. Simply. So in means what? It will check whether the value is present in sequence or not. If the value is present in sequence, it return true. Else it return false. Not in means if really the value is not present in sequence, then not in will return true. Otherwise, it return false. Let's check the things so that you will get clarity here. Suppose here I'm checking print 100 in L. In is a operator. This is membership operator. L is what actually my list sequence. I'm passing the value is 100. Do you think 100 in L? No, 100 is not there in L. So it returns simply what's a false. Look at this, 100 is not available in list sequence, false it is there. Suppose here I'm taking 100 not in L. Yes, 100 not really in list. So it's don't have, you can see 100 value not there. It's correct. True only. And for example, here I'm taking 100 not 10 I'm using. 10 not in L? No, sir. 10 not in L is not correct because 10 is there already in list. So if 10 is there in list, then you are saying 10 not in L. So that is not correct. So it return what? False. 10 not in L is a false because it's already there in list only. Suppose next I'm taking 10 in L. Yes, 10 value is there in the list. So it will return true only, sir. This is for checking, sir. Just so you have huge collection sometimes and you have some group of names in the collection like list collection, set collection, tuple collection. Do you want to check whether the value is present in the sequence or not? All the time the sequence is not available in the program, it's available in some other program. But before going to delete or modification of the number, you need to cross verify whether the number is there or not. If it is there, then you can able to do it changes or deleting. If not there, you can not do it, you cannot do anything like that. So you can able to cross verify so whether the value is present or not. See, the sequence is can be of anything, sir. It is not a list. It can be a string. It can be tuple. It can be set. Anything. Only the thing is we have to pass the value which is present in list or not. We can check this clearly. Okay, 10 in L. 10 in L. Yes, true. That is true. So this sequence can be passed directly here. Yes. No need to place here. You can see we can pass directly here. No need to create any object of list. So 10 in this sequence, yes it is. Even we can also use any string also here. For example, I'm taking Durga Soft is my string and I'm taking in this Durga Soft X I'm checking. So now you can see X I'm checking. X in Durga Soft. A letter X is there in Durgasoft? No. So it return what, sir? False. Suppose here I'm taking D is Durgasoft. Yes, D letter is there in Durgasoft. So it's true only. Any collection we can able to use it, and we can check that values are available or not in the given sequence. So that purpose we use what? Membership operators. So membership operators are used to check whether the value or element is present in given sequence or not. In operator and not in operator are membership operators. In will return true if the value really present in the given sequence, otherwise it return false. Not in will return true if the value is not really present in sequence, otherwise it return false. So these also we will use many times in our upcoming logics compulsory. Before that using, you must and should aware what is the purpose of this. So it will be easy for you in our upcoming session when we use these all operators in our programming. Okay. Now coming to this identity operators. Identity. So what is identity operators? How to use this identity operators in your program? We'll see this. See, identity operators purpose is, identity operators are used to check whether 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 identity operators are used to check whether the objects are variable, whether the variables, or we can say objects, means in Python everything is considered as object. So identity operators are used to check whether the variables are having same identity or not, whether the variables are having same identity, same identity, or different identity. We can able to check, sir. Different identity, whether same identity or different identity, it will check. Identity operators are used to check whether the variables are having same identity or different identity. So what are the identity operators? Is not, these are is not, two are identity operators. These also return true or false, sir, actually. Okay, true or false. So let's see this identity operators. Is will return true. It return what, sir? True. When it return true, if both the variables, both the variables, both the variables are having same identity. Yes, both the variables or any objects also, both the functions also we can use identity, no problem. Anywhere we can use this identity. Is identity operator return true if both the variables are having same identity. If not, it returns simply false. If not, if return simply false, it returns simply false. Is not will return reverse. Now you can see is not return true if if both the variables are really not having same identity. If both the variables are not having same identity, same identity, it return true. Otherwise, it return simply what's, sir? False. Is not will return true if the variables are not having same identity. It return true if the both variables are having same identity. Otherwise, it return false. So is also a keyword, not also keyword. You can check out once keyword list. How to check keyword list in Python? You all know that. So I mentioned clearly in my previous lecture. So now you can see print. I'm trying to import keyword first. Import keyword. Import keyword. Print keyword dot kw list I'm taking. Now you can see this. I'm trying to get this keyword list. So in keyword list, you can just notice this. And is a keyword. So you can see and is a keyword. Just now we discussed and operator. Or is a keyword. Okay. Not is a keyword. In is a keyword. Is a keyword, like this. These are all operators and keywords also. Okay, just I'm showing. Now let's see this how identity operators will work. Like is not. Okay, how it will work. So let's see this is not. Suppose a value I'm taking 10, b value I'm taking 20, b value I'm taking 20. So A value I'm taking 10 and B value I'm taking 20. I'm trying to find the identity of these two. So print A is B. A is B? Yes, A is B. No, A is not B because A value is holding what actually? A is holding what? 10. B is holding what? 20. So that's what here A is not correct. So that's what it is false. So look at this A10, B20, but I'm saying print A is B. So A is B not correct. No, false it is. So because value of 10, value of A is 10, value of B is 20. So the moment when I try to give this 10, now you can see A is B is what? Same. So true it is there. A is B? Yes, A is B only, sir. So what basis it's going to be checking whether both variables are having same identity or not means simple. So there is a built-in function in Python. So what is that built-in function? So I'll tell you that this is very important function. ID function is there. ID is a built-in function. So ID, it is a built-in function. Built-in function. It is a built-in function and it is used to find the memory address of the variable. Memory address of the variable actually. It is used to find memory address of the variable. Okay. And the ID function will return always unique integer. It will return a unique integer, unique integer, unique integer. Unique number will return, sir. This is. In Python, ID is a built-in function. This function is used to find the memory address of the variable and it will return what's are actually unique integer it will return, sir. So because of this id only, so identity operators will work. So look at this, why a is b here in this case. The reason is a holding 10, b holding 10. So this 10 object is pointing to the variable a and b same. Okay, that's the reason actually here it is it is are doing like this 10 and what we can say 10 and 20 here. Let's see this just a moment. I'm trying to draw something like this. So here I'm taking a is there here in this a. So this is what actually we are having this 10 value here inside this 10. This 10 is pointing to what actually a as well as b. So this is pointing to a and b, sir. Clearly you can see this a and b is pointing here, variable a and variable b. So this is a, now here it is b, sir. So that's what identity of A and B is same because A and B values are having same 10. Python will arrange the memory of 10. This is only memory address for the A. So the moment when I try to do this ID function, you can see this. So for example, print ID of A, I want to check. A value 10, ID of A is what number it is? This is the identity number, sir. Look at this. ID function will return a unique integer ID number 600. But every execution to execution ID number might be different. So don't expect same result. Now you can see here ID of A, ID of B, both are having same memory address or not. This memory address is pointing like this here only, sir. Here we are placing this memory address. So A is located at same memory, B variable is located same memory. So it's pointing only 10. So 10, A, 10, B like this memory address is same. That's what here A is B is returning true only. Identity will have same in between these two variables value A and B. So let's go for 20 I'm giving. The moment when I give this A value 10 and B value 20, so I'm taking print A is B not correct, A is not, A is B not correct, A is not B correct. So A value 10, B value 20, memory address will be different. You can see at this moment. So false is there, A is B because A is not B. A and B are not same. ID of A is what? This one. ID of B is what? This one. So this in this case, what's going to happen here? So A here you can see this is 10 and this is 20. Now here it is pointing to different variables. So this is 10 is there here and 20 is there here. 10 is pointing to A and 20 is pointing to B. This memory address is different and this address is different. When Python recognize the variables are different, might be values are same, it will allot same memory for two references. So this is A and this is B are here clearly. So this memory address is same, different, and this memory address is different. If Python is looking like A is holding 10, B is holding 10 for both objects, so memory will be same for 10 values only. Both are pointing to this memory only clearly. But here both are not pointing to the same memory, it's a different memory. So this is where id function will work clearly. So id is a built-in function. It is used to return the unique integer of the memory address of the variable. So a value 10, b value 20, that's what memory address is different. So a is b is false. If I say a is not b, correct. A is not b, sir. A is different, b is different. Correct only. A is not b, correct. So even you can able to use characters like, for example, if I try to use Durga is the word, and here I'm trying to take capital letter Durga, and A is not B exactly correct. A is not correct into B because D small letter is there here, D capital letter is there. ID function also you just check it. It's returning what actually unique integer. It's a different memory address number and it's a different memory address number. Unique integer is different. If I say that small letter D, Durga. Now we can see what is going to happen here. D false. So A is not B, not correct. A is B actually because both are having same memory address. So that's what it is. A is B correct. A is not B, not correct. So this is just identity. In our upcoming session also, sometimes we work with multiple functions. So functions means we can create any number of functions in our program with any names. Sometimes you want to check the function identity, both functions are having same address or not. You can also find that by using identity operators like is not, or identity operators are here. Okay, so these are the identity operators. Identity operators will work based on its id function. Like id function will return memory address. Using this memory address only, it can be able to find whether both variables are having same identity or in different identity clearly. So these are all important operators which we are going to use in our upcoming sessions like identity, membership, logical, assignment, relational, arithmetic. Okay. But as I said that except bitwise operator, you just focus on any operator, it's good. But if bitwise operators also I'm going to discuss, but I'm not going to use these bitwise operators in our upcoming session. Anyway, I'll give you clarity about bitwise operators. Generally, bitwise operators are used to perform bit by bit operations on integers for faster rate of computing or calculations. So find bitwise operators are used to perform bit by bit operations, bit by bit operations on integers. I'm saying integers only, sir. Okay, we cannot apply on any numbers like here bitwise operators, only integer numbers. And generally bitwise operators can be used in computing case like faster rate of calculation, faster rate of computing purpose. We use this bitwise operators. And what are the different type of bitwise operators are there means? So first one is bitwise and the symbol is these ones are bitwise and one is next bitwise or that is symbol is this is bitwise or next one is bitwise XOR that is called XOR that is symbol is cap symbol. And next I'm taking see here bitwise not is there that symbol is tilde symbol, it is negotiate. Next bitwise left shift is there, number of bits can move to left side, that is symbol is this one. Next I'm trying to say bitwise bitwise right shift, right shift. That means number of bits can move to right side only here. These are the bitwise operators, but don't focus much more on it. It just information purpose. I'm giving this bitwise operators explanation, but just keep it the information, and we are not going to use anywhere in bitwise operators concept in our programming clearly. So bitwise and or XOR, not, left shift, right shift only here. Okay. So first of all, in bitwise operators especially, you should aware of that how to convert a decimal number like number into binary form as well as binary form to number form. These two are the main logics here. You should be in a position to calculate number system into what we can say binary system and binary system into number system, because bit by bit means it's completely perform on binary operation, zeros and ones only it will perform. Okay, so that's what we need to do in Python actually. If you want to find any number binary operations, binary values or zeros and ones, if you want to represent any number, integer number, no need to do any manual calculation. So look at this. If I try to do this a value 10, for example, imagine that a value 10, or you can take a value 9. I want to calculate binary of 9 means how we can do this. In Python, there is a function called binary, bin. It's a expecting number, like you can see this bin of number. That number is what? A only, a value 9. So a binary number, how it is 9. So how much it is, if you want to know, directly you can use binary of A. But if I say like directly binary of A, how it will come? 9 value binary value means, look at this here, 0 B means binary format. 1001 is a binary format of 9A, A9 value binary A. So now we can see B equals to, I'm taking like 10 and print binary of what actually B, I can say that binary of B. So what is the binary of B value? 1010, like this only. Look at this, how it came. Okay, we need not to do manual calculation, but I'll show you manual calculation also. But 1001 binary of A is, binary of A9 is 1001. B value 10, binary of 10 is what? 1010. So to know about this calculation, just a moment, I'm trying to open this paint. So let's try to understand this, how we can calculate manually binary of A10, A9, B10 binary values. So to calculate manually, I recommend just you can go for 2. 2 means binary actually here. So you have to mention here right to left, 2 power 0 we have to mention first. Next, what I'm taking, 2 power 1 I'm taking. And it's all not needed actually, just I'm saying 2 power 2 and 2 power 3, like this. Why we should use 2? Because it's a binary, means zeros and ones. Okay, sorry. Again, it's a mistake. It's typical to write in the notepad for me actually. And is this anyhow? 2 and 2 power 1, 2 power 2, 2 power 3. Now let's draw this. Now you can see here I'm taking 2 power 2 and 2 power 3, 2 power 1, 2 power 0, like this. Why we should take 2 only? The reason is binary, zeros and ones. Now you know that 2 power 3 is 8 and 2 power 2 is what? Actually just 4, and 2 power 1 is 2 and 2 power 0 is what? 1. 2 power 1 0, 2 power 0 1. So I'm just calculating here a value 9. I would like to calculate binary of what's our A. So what is that binary of A here? How to do? Find out. It's a very simple processor. Look at this once, A value 9. In this 8421, which numbers if you add 9 will become? Obviously 8 and 1. If you add 9 will become there. We have to point position ones and remaining things are zeros actually. That's what 1001 is the binary of A. Similarly, B equals to what I'm taking, 10. B equals to 10. So here I'm taking binary of what? B. How to calculate this binary of B means, just which number if you add 10 will become, you can think once, 8 plus 2. if we add 10 will become on that positions we can take ones and remaining positions are going to be zeros. So this is very simple calculation, but not required. This is the reason is in Python there is a built-in function like binary function. Using that function directly, we can able to what we can say find the binary of any number like this. So a value 9, binary of a, how I'm calculating. So 8 plus 1, if you add 9 will become, so on that positions ones, remaining position 0. B value 10, binary of b. So 10 means 8 plus 2, 10, 1, 1, in that positions 1 ones and remaining 0. So binary of a 1 0 0 1, binary of b that is 1 0 1 0, that is 10 value. So we got same output or not? Yes. This is direct calculation. We can apply binary function, and this is manual calculation how to do it. But I don't want to do this one. I want to do what actually. Look at this. So binary of a and b I need. Just a moment. So you can see this here. I'm taking binary of a and b's are here. Binary of a and b. The binary of a and b, how we can call it as, you can see this binary of a and b means 1 and 1, 0 and 0, 0 and 1, 1 and 0. And means you know that both true means true, both false means false. One of the condition is true means what? False. And again false. So look this 1 0 is binary of a and b. So let's see this whether it is correct or not in my programming. Print binary of a and b, binary of a and b. So the moment when I run this, so we got the output here, binary of a and b. So what is the output? You just check and compare. 1000, we got it. So whatever we did this 1000 in my logic, that is correct. Even if you don't know about how to do it, 1 1 0 0 0 and 1, 1 and 0, I recommend to open the truth table. So in my documentation, I have clearly mentioned the 4-bit operation truth table. You just go through them. So I can mention, I just mentioned in this documentation clearly 4-bit operation truth tables are. Let's say a moment. I'm just going to click on. So this is 4-bit operation truth table. You can just observe here this one. Bitwise operators truth table. So focus on it here. So this is 4-bit operation truth table. So a value, b value. So when I say this 1 and 1, so you can observe carefully in this diagram. A value 1, b value 1, 1 and 1, 1 only. 0 and 0, 0 only. 1 and 0, 0. 1 and 0 0 like this. So this is, you can observe. If you don't want to go for manual, you can take this table and you can observe and calculate. So this is binary of a and b only. But sir, I don't want to do binary of a and b. Can I convert this binary form like 1000 to back to the decimal form like number form? Yes. You can see I am trying to calculate binary of a and b, not only a and b I want to calculate. To do this, simply you can reverse it. 0 into 2 power 0, I'm taking 2 power 0 plus again 0 into 2 power 1 and again 0 into 2 power 2, 2 power 2 and 1 into 2 power 3. So 1 into 2 power 3 like this. So the result is what actually, sir? This is, sir. Let's moment. The result is like this. If you are converting binary of a and b into only a and b values, so I'm converting this binary into decimal form again. So this is 2 power 1 into 2 power 3, 8 plus 0 into 2 power 2, 0 plus 0 into 2 power 1, 0 plus 0 into 2 power 0, 0. So how much it is? Only a and b. Only a and b is what? 8, sir. Look at this. Only a and b I'm trying to 8. How it is? That is only calculation manually what I shown. A and b is 8. You may get doubt why, how a and b is 8, because we just calculated manually as well as programmatically. But this is programmatically directly we can do this. A and B is 8 is coming. How 8 is came in the sense you have to be convert that into decimal form back in my paint option which I'm showing. It's converting like this only. 8 value is there. So this is what actually bitwise and same thing we can apply or means this is now. I'm going to change the scenario or bitwise or. So let's go for binary of A or B it is. Let's binary of A and B it is. So let's binary of A or B now. So let's remove this. So this also I want to remove because it is not correct calculation of A or B. So everything is different sir now. So this is manual calculation. If you want, you can go through this. So just I'm showing for your understanding point of view. I'm finding bitwise A or B, bitwise A or B. Now you just go to there. So we have to consider one or one only because our condition both are true only. Zero or zero, zero, zero or one or zero, one. So now we can see in the truth table also you can observe here one or one truth table A value 1, B value 1 or 1 only. Now again here 0 or 0, A value 0, B value 0, 0 or 0, A or B 0 only. Next 0 or 1, 0 or 1 in the sense this is 0 or 1 that is 1 only here. Same 1 or 0, 1 only here. So binary of A or B is 1 0 triple 1 0 double 1. Is this correct binary of A or B? Yes. Let's try to do this in our program. Binary of A or B. R symbol is this one only binary of A or B. So this is what A or B 1 triple 0. Yes, obviously that is 1 triple 0 only. Sorry, 1011. So what we got here? So 1011, correct. 1011 we got in the output also 1011 we got this binary of A or B. But sir, only A or B value how much it is? Binary of A or B is okay. Only A or B 1 into 2 power 3 8 plus 0 into 2 power 2 0 plus 1 into 2 power 1 what? 2 only plus 1 into 2 power 2 0 1 only. 8 plus 2 plus 1 11. Only ARB is what? 11 only. Look at this. Only ARB, it's 11. Only ARB is 11. You got 11 or not? Yes. How 11 came? We are converting into binary of ARB 1011 into decimal format. We are converted. So this is bitwise A uh, bitwise OR operator. Next, bitwise XOR is there. Exclusive OR it is. So here cap symbol is there. No, this is exclusive OR symbol. So exclusive OR means we have to do changes again. So let's see this bitwise exclusive OR. I'm just changing this one only. The symbol I'm changing. Instead of this, I'm giving cap symbol. And calculation will be different, sir, now. AR, A exclusive OR B. So we have to change this. So exclusive OR B means like. So this I'm removing. And here also I'm removing. This is not correct way to do. Yeah. So we can observe the truth table while performing XOR. So one exclusive OR 1. So look at this truth table. A value 1, B value 1. Exclusive OR means 1. Both are same bits, then opposite bit will come like 1 1 0 0 0 0. Okay, 1 1 0. When it will become 1 means any one is 1, that is 1 only. Exclusive OR. Otherwise it is 0 only. Both are same bits, 0 is the fix. Any one of the bit is 1, that is 1 only. So you can see this here. I'm taking this one 1 1 0 and 0 0 0, and now you can see 1 1 0 0 0 0 1 1 0 0 0 0 exclusive are okay. Yes, next 0 1 1 1 0 1. So binary of A exclusive RB is 1 1 only. Left side zeros are there, it won't be appear here. Now print binary of A exclusive or B, A cap B. So what is this? Look this ones. binary of A exclusive or B, that is A cap B. So 0 B double one is there. Yes, it is correct. 0 B double one only. But only exclusive only A exclusive or B is what? Not binary, only exclusive or B. So that is decimal form converting. This is what actually 2 power 3 into 0, 0 plus 0 plus 2 plus 1. That is what? 3 only. So only A exclusive or B value is how much it is? 3, sir. Just a moment. A exclusive or B, that's it. 3 only. Now you can see 3s are here. So this is binary of A exclusive or B. So we have one more operator is there, like bitwise operator not. Not means you just focus on it here. Table, truth table especially. Not means negotiate. False means true, true means false, like that. So A value 0 is there. Tilde A means not A, not 0, 1. A value 0, not 0, 1. A value 1, not 0, not 1, 0. A value 1, 0. So here bits can be reversed. That means ones will become zeros and zeros will become ones. Based on that, it will be calculate. I'm just giving the direct formula for this negotiate A. So there is a formula is there, standard formula. So for example, tilde A, I'm using the A equals to minus of A plus 1. This is a standard formula. This is exactly okay. Tilde A is minus of A plus 1. A value, how much I have mentioned in my programming? 9. A value 9, sorry, you can see 9 on top. So 9 minus of 9 plus 1 in a sense minus 10 only here. This is the standard formula for negotiation. So tilde n equals to minus of n plus 1. Here tilde A equals to minus of A plus 1, like this. Now coming to this, two operators are there again, last bitwise left shift and then right shift. Here left shift means number of bits whatever you mention, that bits can move to left hand side. Right shift means number of bits can move to right hand side. So let's see this practically how it will move left side and right side clearly. So let's clear this all the stuff which I included. So let's quickly clear it and I can extend this how number of bits can move to left hand side as well as right hand side. We will look into that. Okay, just a moment. So let me clean it and so that I can show you clearly number of bits can move to left side and right side, how it will be. It's difficult to handle this paint actually, not a problem. If it is Windows 10, it's easy to manage for us to big size eraser or something like this. At this moment, I'm not able to find in Windows 11 what's the shortcut keys and all. It's okay. Yeah, fine, sir. Now you can see this. Left shift, right shift means obviously moving towards the left side and moving towards the right side. That's what I'm enhancing. That what we can say 2 power 4 again. Here I'm taking 2 power 5. Two steps I'm enhancing. Why? Because I need to move towards 2 bits left side and right side. 2 power 4 is 16. 2 power 5 is what actually 32, sir. Okay. Suppose A value 9 I'm taking as per my programming. A value 9. 9 binary format is this one only, no, sir. 1, 0, 0, 1. So this is. I am taking A less than 2. That means 9 less than 2. Why 2? Because 2 bits only I want to move towards left side. Number of bits can move to left side here. 2 bits, 2 means 2. 3 means 3 bits also you can move left side, no problem. So I am giving 2 bits only, no. 2 bits means 2 positions will move left side. That means 1 will become at the position of 32. This 0 will be placed at 16 and this 0 will be placed at 8. Now you can see this 0 will be placed at 8. Now this 0 will be placed at what actually? Now we can see this 0 will be placed at what? 1 only, sir. 1, 1. This 0 will be placed at 1. 2 bits can move to left hand side or not? Yes, exactly. 2 bits can move to left hand side. 2 bits can move to left hand side clearly. So 2 bits are moving left side. Now after that you can see this here. I'm trying to just place this, and now coming to this 32 plus 16 into 0, 32 into 1, 32, 16 into 0, what actually 0, plus 8 into 0, how much it is 0, plus 4 into 1, how much it is 4. Now we can calculate 32 plus 6, 32 plus 4, how much 36. After moving 2 bits towards the left side, a equals to 9, 9 less than 2, 32 plus 4 is how much at actually 36 only. Let's see this whether it is correct or not. We'll look forward. So print a less than 2. That means what? 9 is the a value, 9 less than 2. Result is how it will come. After moving 2 bits towards the left hand side, the result is coming like 36 only. This is 36 exactly. At the same time, we can try to do 2 bits moving towards the right side only. So I'm trying to do right hand side moving 2 bits. So after moving, you should be calculate like this, sir. How to do it? We'll see this. Just give me 1 second. Now you can see. So 2 bits means I'm trying to say a value greater than 2, 9 greater than 2. 2 bits I'm towards moving right side only. If 2 bits position is changing, then obviously here 1, 0 will come here, and this 0, 1 will go there here out of this value. So we should calculate only 2 into 1, that is 2, plus 1 into 0, that is 0. But these values are don't have any values 2 power 0 after, that is negative numbers not required. So 2, 1 means 2, 1 into 0 means 0, 2 means 2 only, that is. So 9 greater than 2, that is 2 value. Look at this, print a greater than 2, this is 2 only, sir. This is overall calculation of bitwise manually as well as programmatically. I can show you directly this program. It's simple for us. So A value 9, binary of A how it is, binary of B is how it is, like that only. But you may ask that how it is came like this, how it is possible to bring these values. Means manual calculation also I did. So this is the manual calculation. So I'm saying don't concentrate on this bitwise operators, because anyway we are not going to use this bitwise operators more in our upcoming programming. Better to concentrate on other operators like identity, membership, logical, assignment, relational, arithmetic, and so on. Okay, so that's all about this today's session. And tomorrow I'm going to start and most important things, which is completely logical part of the programming, that is control flow statements. Control flow statements means conditional statements, iterative statements, transfer statements. Conditional statements means completely if else, nested if, elif. Iterative statements means for loop, while loop, nested for loop. And transfer statements means break, continue, pause. This is completely logical aspects. Once you understand these logical statements, then it is easy to move towards our string data structure and its complete operations, list data structure and its complete operations. All we'll discuss in detail once we complete these logical statements. So that's all from my side today. So if you have any question from your side, you can feel free to ask me here.